All right, here we go. So when reactions are thermodynamically unfavorable, meaning that their delta G is positive, okay, there are ways to force the reaction to occur. Okay, so for example, your cell phone or your Chromebook battery, okay, that when it's using the battery, that is going to be a negative delta G. That reaction is favored. But then you have to get that thing recharged, right? So if one direction is a negative delta G, going the other direction must be a positive delta G, right? So there must be some way or ways that we can make this happen, okay? And the way you do it is you plug it into the wall with a charger. That charger, okay, that power supply is going to overcome the unfavorable positive energy. Light is another way that we can do it in certain reactions. In photosynthesis, so remember, you've got photosynthesis that goes one direction, right? That is a positive delta G. What's the opposite of photosynthesis? What's that called? Cellular respiration. Okay. So cellular respiration is the reverse of this. So we have to go, that is a negative delta G. This is what's happening in every cell mitochondria in your body right now. If this stops, you die within about 6-7 minutes. You're brain dead, or you're brain dead in like 4, and then you're completely dead in like 6 or 7. That's about all the reserve. That is the reserve that your body has to keep you going. It's about 6 or 7 minutes. And then those mitochondria die and you die. Okay? On that happy note, photosynthesis then is the reverse of that. So it's going to have a positive delta G. A positive delta G then requires an external source of energy. In photosynthesis, that is light. Light provides that extra boost. Okay? So they are going to be able to drive reactions forward that are normally unfavorable. So those are a couple examples from your life that you're kind of aware of already where this happens. Another way to do that is to couple it to a reaction that is thermodynamically favorable. So the delta G of the thermodynamically favorable reaction is going to be greater than the delta G of the unfavorable one. And by coupling it together, it can get the energy reserve from this and use it for its reaction. So for example, here we've got this, okay? This is a positive delta G. So this reaction is not thermodynamically favorable. This is a negative delta G. It is. So if we couple these reactions together, then we can end up with a reaction that is overall thermodynamically favorable. Okay. And we had talked about these back in, I want to say unit 5, when we had done kinetics, where you can flip these around and, we end up having to cancel out electrons. Remember doing that? Yeah, fun times. Okay. Biological systems often take advantage of this coupling in order for unfavorable reactions to be driven. All right, here we need to write an overall reaction. And would this be a good example of a coupled reaction? All right. So here we have, what is this A2 called? What vocabulary term do we give A2?
A2. I know what it is, but like intermediate.
Yes, very good. Thank you. See, good thing he showed up this morning, huh?
Yeah.
Okay. Yeah, this is an and I didn't get all my blanks drawn out, but yes, this is an intermediate. So we are going to cross it off. Okay. And then our overall reaction is what's left. So we have A2B3 plus C yields 3B plus A2C. Our overall delta G here is going to end up being how much? You should be able to do this in your brain. 30. That is a positive value. So would this be a good example of a coupled reaction? No. In order to be a good example of a coupled reaction, your delta G needs to come out as a negative value. And that's not the case here. All right. So our next one here, we are looking at all right. So we're given our reaction here. We're going to figure out if this is a this reaction right here, is this thermodynamically favorable? No. Why? Delta G is positive. Okay. If this reaction were coupled with this one, would the coupled reaction be favorable? And we need to show the overall reaction and calculate our delta G for support here. All right. So I have up here, I have 2Ag2O 4Ag and O2. So here, I need to get this up to a full O so that these guys can cancel out. Okay? Because this is on one side, this is on the other. You see that? So what do I do to get this up to a full O from a half O? Huh? Yep, I have to double everything. So I'm going to double everything, but that also means that I've got to double this guy. Okay? So I'm going to double everything here. I'm going to end up with 2C plus O2 yields 2CO. This would have been 21.9. And this would have doubled this, which would have given me a negative 274.6. All right. My oxygens then cancel out. I'm not seeing anything else that cancels out. So show the overall equation. So I've got to combine these. So 2Ag2O plus 2C. It's going to yield 4Ag plus 2CO. And then when I do my math here, that comes out to a negative 252.7, and that's going to be kilojoules.
So it is thermodynamically favorable.
Yes, it is. Yeah. So would the coupled reaction be favorable? The answer there is yes. All right. Questions, issues, problems, thoughts? Tomorrow is just going to be a work day because I'm going to have too many people gone. I can already see that people are starting to drop off without even letting me know about it. So,
Are they on vacation?
what?
Are they